All right, so again, find the length of each leg of an isosceles right triangle with a hypotenuse of 24 inches to the nearest inch. So the definition of an isosceles triangle is any triangle with at least two congruent sides is an isosceles triangle. So if it's two congruent sides, we can do these two kind of look the same, and we'll make this one the isosceles. So if these two, I'm sorry, this is the diagonal. So if these two sides are congruent, now let's plug in the numbers. Find the length of each leg, so these two, of an isosceles right triangle. So this is a right triangle with a hypotenuse of 24 inches. Okay, so because it's the same length, we can actually just use substitution. Instead of doing a squared plus b squared, we could just do a squared plus a squared, because it's the same size, because they're congruent. So equals 24 inches squared. So we have 2a squared equals 24 24 times 24 is 576. Now we can divide this by 2. A squared equals 288. Okay, so let me just read the question again really fast. It says find the length of each leg of an isosceles right triangle with a hypotenuse of 24 inches to the nearest inch. That's kind of important. To the nearest inch means they don't want approximation. I mean, they want an approximation. So even if it's point something, we can round up. Okay, so it's not asking us to be exact. So let's try to do. Well, let's just go ahead and see what the square root of 288 is. The square root is 16.97, which I would say is very close. So approximately 17 inches. Okay, and you would just use the approximate signal. So so make sure that you read the questions very carefully. It did say up to the nearest inch, so it's okay to round up if it's close. All right, so I hope that made sense to you, Sarah. Let's go to the next question, which is lesson 30, also number B. And this is doing a proof, a 2-column proof. Okay, so it says prove that, okay, and we have here two, this is what it looks like. It looks like the bow tie that we did in class the other day. Maybe I should make this a little bit bigger. Okay, so we have B, A, C here, and D, E here. These are parallel, and they're also congruent. So it says prove that triangle ABC is congruent to triangle DEC. Given that, okay, so let's go ahead and do our statements here and our reasons over here. Okay, so we have, I'm going to use a different color pen just to kind of highlight what I'm doing. So the first thing is we're going to write down the givens. Okay, so the given is that AB, segment AB is congruent to segment DE. So AB is congruent to segment DE, and also that AB is parallel to DE. Okay, and then we're going to just write here given. This is the given statements. Okay, so let's take a look. Before we actually start writing everything, let's figure out what we're going to do. So I believe the easiest thing for me to do is, since we know that these are parallel and we know that any transversal of two parallel lines, we can actually show that the alternate interior angle, so remember, if this is, I'm going to extend the line out a little bit so I could see the line more clearly. It actually helps me. So let's just say take this diagonal for right now. Alternate interior angles, which would make this one right here and this one, they're alternate interior angles. they are congruent. I can't remember what the postulate or the theorem is, but I know it's there. And if that's the case, then this diagonal over here will also give these two alternate interior angles will also be congruent. Okay, and with those two angles, so angle, and we have a side here, an included side. I know that there's a theorem or postulate for that. I can't remember what it is, but we'll look it up. So let's go ahead and use those three to prove that these two triangles are congruent. So we'll do the measure of angle, we'll take this one to BAC, is congruent to the measure of angle EDC. And I'm going to find out what that postulate is in just a second. And we're also going to use the same reasoning for these alternate ones over here. So the measure of angle ABC is congruent to the measure of angle, what is this? Okay, so ABC, so DEC. Right? Yeah, DEC. Okay, so let's find out what that postulate is, and it is theorem 10. And what I did was, before doing this, is I looked back here to look at the postulates, and we have here's theorem 10.1. Can you see that? Which says alternate interior angle theorem. If two parallel lines are cut by a transversal, then the alternate interior angles are congruent. Okay, so that's the theorem we're going to use for both of those angles. Okay, so and we're going to put here alternate interior angle theorem. And we're using it for both of these, so we're going to put theorem 10-1 also, alternate interior angles. Okay. And so basically we've already proven it by angle and then included side and angle. So now we can say that triangle BAC is congruent to triangle BAC EDC. Okay, and through what angle, side, angle. Okay, and that's I can't remember if it's a theorem or not. Angle, side, angle is postulate 16. So angle, side, angle, or postulate 16. Hope that helps, Sarah. Okay, so I'll go ahead and move on to the next one so we can finish up here. Okay, I'm going to do just one more because I'm running out of space here on my video. So lesson 30, number 11. Number 11 says, okay, determine the value. Oh, this is easy. Okay, so determine the value of x. Okay, you probably just totally missed this one because as soon as I show you, I'm sure you're going to be like, oh my goodness, I should have caught that. All right, so we have T, U, V, and I, J, or H, I, J. Okay, and we know that angle J is congruent to angle V, and HJ here is congruent to TV, to segment TV. And did you notice that IJ is 12 and UV is 12? That means that they're both congruent. So if we have two congruent sides and an angle, we have a congruent triangle. Okay, so they're all the same. So this angle right here is 63 degrees. This is 54 degrees. And this over here, we just know it's 9x. But if this is a congruent triangle, then the same side is congruent, the same angle is congruent. So we have H, which is the one that you're trying to find out. So we could just plug in the numbers. 54 degrees is the same as 9x. So divided by 9, x equals 6. That's it.